podcast, we're going to talk about types of chemical reactions. I'm going to start talking about different types of chemical equations. The first type is synthesis. Synthesis is going to be the combination of two or more substances to form a compound. Basically, the big hint here is that there's only going to be one product. There's only going to be one thing on the right side. So you see you have A plus B yielding AB. That's the AB form, which would be like little blue molecule plus little red molecule equals a molecule that has a blue and red atom combined. All right, here's an example of synthesis. Here we have H2 and Cl2, so hydrogen gas and chlorine gas, and they are forming hydrochloric acid gas, okay, vapor form. An analogy for synthesis would be taking different puzzle pieces and adding them together to make one puzzle. Or if you had a guy and a girl going to the prom and they both went single by themselves, and then when they got to the prom, they started dancing and hanging out together. Okay, so they started off by themselves as two separate entities, and then they ended up as one entity in the end, couple. Okay, the next type of chemical reaction is called decomposition. Basically, it is the opposite of synthesis. It's when a compound is going to break down into two or more simpler substances. The big hint here is you only have one reactant. You only have one thing on the left side. So you have AB, a compound, breaking down into simpler form of A plus B. Okay, so here you see the compound, the blue and the red together, and then over here, separate blue and red. Okay, an example of this would be water being decomposed into hydrogen and oxygen gas. And then here are two other examples. We have the flour, and the flour breaks down into many different pieces as it dies. It decomposes. And then you have the egg, and the egg breaks, and you have just the broken shell and the chick, so it decomposes into simpler form. Okay, another example would be if a couple went to prom and then broke up at prom. So they started out together and then they broke up into two simpler forms. All right, single replacement. Single replacement is when you have one element replacing another in a compound. If you have a metal by itself in the beginning, then that metal is going to replace the metal in the compound, or the positive one in the compound. And if you have a non-metal that's by itself in the beginning, it's going to replace the non-metal, or the negative one in the compound. Okay, so here in this instance, we have A. A comes in, kicks out B. Now, A and C are together, and B are by themselves. Okay, basically you get one person coming in and kicking the other one out. All right, here's an example. You have copper and silver nitrate, and the copper comes in and kicks the silver out, and now it's copper nitrate and the silver is by itself. All right, an analogy for this would be if you were listening to CDs on a CD player. I know how old school, right? And you took your CD out and traded it for a new one, okay? So the first CD that was in there was the compound, and you have a CD by itself. And then in the end, you take the first CD out, it's now by itself, and the second CD is in there. Another example would be if a guy and a girl went to prom together as a couple, and then at prom, the girl saw a guy that was a little bit cuter than her date, dumped him for the new guy, and then the guy that was her date is now alone. Okay, so basically getting replaced by someone. All right, double replacement is when you have two ions in two compounds, and they're going to change partners. So the cation, or the positive one of one compound, is going to combine with the anion of the other. So the positives will switch places, basically. Okay, so in this case, we're going to see AB together and CD initially, and then B and D are going to swap places. A is now with D, and C is now with B. Okay, so you have a swapping of partners. An example of this would be if you have lead nitrate and potassium chromate, And then the lead and the potassium swap places. Okay, so now the lead and the chromate are together, and the potassium and the nitrate are together. Okay, an analogy would be if you had two friends, they approach one another, they each have something in their hand, and they trade what's in their hand, and then leave. Okay, another example would be if you had two different couples that went to prom together, and then when they got to prom, they decided that they'll just swap partners, they'll swap dates, and that would be an example or an analogy for double replacement. All right, the last type of reaction is going to be combustion. The combustion is the burning of any substance in oxygen, O2, and it's going to give you heat. So basically it's A plus O2 yields B. Okay? Most commonly, combustion will be referred to in the form of hydrocarbons, which can be any carbon and hydrogen combination reacting with oxygen. They always, always, always make carbon dioxide and water, so CO2 and H2O. Okay, so here's everything I just stated before, and a couple more examples. Okay, so this first one is not a hydrocarbon, it's just a metal reacting with oxygen, and it forms the metal oxide. Okay, no need to memorize that. And then what we'll usually be dealing with will be the hydrocarbons, carbon and hydrogen, react with oxygen, and they always, always, always make CO2 and H2O. Okay, so you will be responsible for remembering that. Okay, and that would be all the types of reactions we're going to cover.